Welcome to the world of online learning. I am Dr. G.K. Viju, Professor, University of Garden City, Khartoum, Sudan. We at GK Online Learning Tutorial emphasize on the topics from software engineering, project management, quality management, strategic management, and mathematics. Today we are going to discuss the topics from software engineering. Please subscribe to our channel for continuous support. Let us start with introduction. This course contains 4 modules and 7 chapters. The contents are Introduction to Software Engineering, Software Development Lifecycle, Requirement Analysis, Problem Without SRS Document, Decision Tree, Decision Table, Formal System Specification, Software Design and Design Strategies, Software Analysis and Design Tools, Structured Design, Object Modeling using UML, use case diagram, class diagram, interaction diagram, activity diagram, state chart diagram, coding, testing, debugging, software maintenance, software quality, CMMI, software project planning, heuristic techniques, COCOMO model, software level estimation, project scheduling, organization structure, risk management, computer aided software engineering or case tools, software reuse, and reuse approach. The recommended textbooks are Introduction to Software Engineering, Fundamentals of Software Engineering, and Software Engineering, a Complete Reference. So, introduction. The term software engineering is composed of 2 words, software and engineering. A program is an executable code which serves some computational purpose, or in other words, program provides a computer or other machines with the coded instructions for the automatic performance of the tasks. Software is more than just a program code, and software is considered to be a collection of executable programming code, associated libraries, and documentation. In other sense, software is a set of instructions, data, or program used to operate computers and execute specific tasks. Software, when made for a specific requirement, is called software product. Engineering, on the other hand, is all about developing products using well-defined scientific principles and methods. 3 types of computer softwares are system softwares, programming softwares, and application softwares. So we can define software engineering as an engineering branch associated with the development of software product using well-defined scientific principles, methods, and procedures. Or software engineering is a systematic application of engineering approaches to the development of software. Software engineering is the subfield of computer science. There are other definitions for software engineering. According to IEEE, software engineering is the application of a systematic, disciplined, quantifiable approach to the development, operations, and maintenance of software. According to different textbooks or different authors, software engineering is the act of applying a collection of techniques, methodologies, and tools that helps with the production of a high-quality software system with a given budget before a given deadline while changes occurs. And according to Software Engineering Yellow Pages, software engineering is intended to mean the best practice processes used to create or maintain software, whether for groups or individuals. So let us recall some histories of software engineering. When the first digital computers appeared in the early 1940s, the instructions to make them operate were wired into the machine. But practitioners quickly realized that this design was not flexible and come up with the stored program architecture, which is also called as von Neumann architecture. Thus, the division between hardware and software begin with the abstraction being used to deal with the complexity of computing. Programming languages started to appear in the earlier 1950s, and this was also another major steps in abstraction. Major languages such as Fortran, Algol, COBOL were released in the late 1950s and 1960s respectively to deal with the scientific, algorithmic, and business problem respectively. David Parnas introduced the key concept of modularity and information hiding in 1972 to help programmers deal with the ever increasing complexity of software system. The origin of the term software engineering has been attributed to various sources. The term software engineering appeared in the list of services offered by companies in the June 1965 issue of Computers and Automation and was used more formally in the August 1966 issue of Communication of the ACM. In 1984, the Software Engineering Institute was established as a federal funded research and development center in United States. Watts Humphrey founded the SEI Software Process Program aimed at understanding and managing the software engineering process. Modern, generally accepted best practices of software engineering has been collected and published as the software engineering body of knowledge. So this is the history of software engineering. Let us go with software engineer. So who is a software engineer? A software engineer is a licensed professional who is schooled and skilled in the application of engineering discipline to the creation of software. Or in other words, we can tell they have extensive knowledge of programming languages, software developments, and computer operating systems, and they apply engineering principles to the software creation. By applying these engineering principles to each stage of the development process, from requirement analysis to the software process, they can create customized systems for individual clients. Just like a civil engineer will make sure that a bridge has a solid foundation, a software engineer will also begin with the thorough study of requirements and work through the development process in a systematic way. There is always a confusion between software engineer and a programmer, but they are vastly different disciplines. While a programmer creates the code that makes the program run, a software engineer creates the design the programmer implements. Computer scientists, they provide theorems about algorithms, design languages, defines knowledge representation schemes, and have infinite time. Or a computer scientist is a person who has acquired the knowledge of computer science, the study of the theoretical foundations of information and computation and their applications. Computer scientists can also focus their work and research on specific areas such as algorithms and data structure development and design, software engineering, information theory, database theory, computational complexity theory, numerical analysis, programming language theory, computer graphics, and computer vision. Engineer develops a solution for an application-specific problem for a client, uses computers and languages, tools, techniques, and methods. Software engineer, they will work on multiple application domains, have a limited time, while changes occurs in requirements and available technologies. The essential software engineering skills. The software engineering skills are the important factors for software engineers or software developer in order to effectively perform a leadership role in a software development project. So general problem engineering skills are communication skills, feedback, motivation, analytical, project management related skills like planning and tracking, risk assessment and mitigation, and then estimation. The top 10 software engineering skills are professional qualification and certification, programming and coding skills, problem-solving skills and logical thinking, team management skills, training and coaching skills, high degree of creativity, planning and executing skills, project management skills, expertise in automation tools, and expertise in best coding practices. Software engineering is considered as a problem-solving activity. They are divided into two sections, analysis and synthesis section. In analysis, understand the nature of the problem and break down the problem into pieces. This means analysis is breaking down the text or problem that you are examining in order to understand each individual part. Synthesis, solve them and put the solutions together to solve the original problem. For problem solving, generally we use techniques or methods. They are formal procedures for producing result using some well-defined notations, or in other words, software engineering methods are just different ways of approaching software development and delivery. Methodologies, collection of techniques applied across software development and unified by a philosophical approach. tools. They are the instruments or automated systems to accomplish a technique. In other words, a programming tool or software development tool is a computer program that software developer use to create, debug, maintain, or otherwise support other programs and application. Then comes the next term. Software engineering is considered as a multidisciplinary discipline since it's a blend of many older science and engineering disciplines like general problem solving ability, social and behavioral science, business and economics, statistics, system engineering, project management, computer science, information storage, processing and management, and finally networking. Software development. Software development is the process of conceiving, specifying, designing, programming, documenting, testing, and bug fixing involved in the creation and maintenance of applications, framework, and other software components. Software development is a process of writing and maintaining the source code, but in a broader sense, it includes all that is involved between the concept of the desired software through to the final manifestation of the software, sometimes in the planned and structured process. Therefore, software development may include research, new development, prototyping, modification, reuse, re-engineering, maintenance, or any other activities that result in software products. So general phases are requirement phase, in that functional and non-functional requirements, constraints, interface to other systems including user interface, design, domain model and implementation model, construction, testing, different levels of testing like unit testing, integration testing, system testing, user acceptance testing, regression testing, specified testing like performance, security, load, stress testing, etc., operations and maintenance, deployment, and change management. The characteristics of a good software. A software product can be judged by what it offers and how well it can be used. This software must satisfy on the following grounds: operational grounds, transitional grounds, and maintenance grounds. Operational grounds. This tells us how well software works in operation, and it must be measured on budget, usability, efficiency, correctness, functionality, dependability, security, and safety. Transitional. This aspect is important when the software is moved from one platform to another. Portability, that means the quality of being light enough to be carried. Interoperability, the ability to exchange and use information. Reusability and adaptability. Maintenance. This aspect briefs about how well software has the capabilities to maintain itself in the ever-changing environment. Modularity or standards. Maintainability, flexibility, and scalability. This is the end of the first session. If you are having any queries, please mail to me to the mail ID given in the slide. Thank you.